For more videos like this for Discrete 1, you can take a look at Sarai Studies, link is in the description box below.
Here are two propositions. They are propositions because they could either be true or false, not both. So it could be true or false that I studied, it could be true or false that I passed my exam. Now my first point is, just like in algebra we represented numbers with variables like x, we can represent propositions also with variables like p and q, or x or y if you want, but usually in discrete we use p, q, r, and s. So I can say that this is proposition p, and I can call this proposition q. So that is how you represent propositions. Now, a second thing I want to do for you today is transition you from what you know about propositions, which is basically what they are and how to represent them, to something called a truth table. So let's say that I'm a student and I have an exam tomorrow, and I simply want to know all of the different case scenarios that can occur regarding if I studied or if I passed my exam. One case scenario would be that it's true that I studied and it's also true that I passed my exam. Another case scenario would be that it's still true that I studied and yet somehow, some way, it's false that I passed my exam. So I did not pass my exam even though I studied. Another case scenario would be I did not study. So it's false that I studied, but it's true that I passed my exam. So I got lucky there. Another case scenario would be that it's false that I studied and it's also false that I passed my exam. So I did not study and I did not pass my exam. Those are all of the possible case scenarios. And that's great and all. But what if I had 4 propositions instead of 2? So I had P, Q, R, and S, and I wanted to find all of the possible case scenarios here. Well, I can use the same logic as before. I can say they could all be true. That's one possible case scenario. Another one is that these can stay true and then this one can become false. Another case scenario would be that these two stay true and then these bottom ones are false. And you can see how quickly this can become messy because you might lose track, mess up, or even not think of a case scenario and miss one. So the question I propose is there an easier way to do this? Is there a systematic and automatic way where I don't even have to think in order to get all of the truth values of however many propositions I have? And the answer is yes. You can use something called a truth table. So how do we construct a truth table? Well, a table is made up of rows and columns. So let's first ask, how many columns should we have? We should have 1 for each proposition. So we have 2 propositions, so we will have 2 columns for the 2 propositions. Now, how many rows? The number of rows is always 2 to the n, where n is the number of propositions we have. So again, we have 2 propositions, so the number of rows in this case is going to be 2 to the 2nd power, which is 4. So we will have 4 rows. Now, how do we fill up the truth table? Well, you're going to take this number right here, the number of rows divided by 2, and write that down here, and you're going to keep dividing by 2 until you get to 1. Now, to fill the truth table up, you're going to use these numbers. So this number tells you how many truths and falses you're going to have to start off with. And you always want to start with truths. You don't need to, but professors like when you start off with truths because it's easier for them to grade. So we're going to have 2 truths. We're done with our truths. Now we move on to our 2 falses. So remember, we start with truths and then we move on to our falses. We're done with this column, so we move on to the next. This one tells us we're going to start off with having 1 true and 1 false. So we start with our truths, we're done, we used it up, then we move on to our falses. We can only do 1, we used it up. But now what do? We still have some space left. The answer is you copy and paste the same pattern that you have until you run out of space. So I'll take this, copy and paste it, I ran out of space, I'm done with my truth table. And it will always work out nicely. You won't have like a extra true or false laying around. Now what we just did is find all of the possible case scenarios of P and Q, or in what we call in discrete, all of the possible truth values of P and Q without even having to think. So one of the case scenarios is that it's true that I studied and it's true that I passed my exam. Another would be it's true that I studied and it's false that I passed my exam. Another would be it's false that I studied, so I did not study, and yet it's true that I passed my exam. And finally, both false. It's false that I studied, so I didn't study, and it's false that I passed my exam, so I did not pass my exam. So to review, the number of columns, you have to have at least 1 for each proposition. And the number of rows is always 2 to the n, where n is the number of propositions. In this case, 2, so we ended up with 4 rows. And finally, we realized that a truth table is used to easily find all of the possible case scenarios, or what we call discrete truth values, of any number of propositions. In this case, we had 2 propositions. And we found all of the truth values without having to think and without having to go, oh, this could be true, this could be true, this could be false, this could be true, and then getting lost and probably missing one. Now, keep in mind that this is a very simple truth table because we have very simple propositions. These are actually what we call atomic propositions. Atomic as in small. They can't get any smaller than this. What's a counterexample? If you had a proposition like this whole thing can be called proposition P, but it's what we call a compound proposition because we could break it up into smaller propositions. We can call this one proposition R. It doesn't matter what variable you pick. We can call this one proposition S. So this compound proposition is made up of atomic propositions. So if you want to make a truth table for this compound proposition, it's going to look a little bit different, which is what we're going to talk about in the next video. So see you then.